The integration rules for definite integrals are basically the same as those for indefinite integrals, that is, those without the limits here. So there's not so much to say about these as we haven't already said, but let's see some examples. For example, for this integral here, then using the first rule, this is just the difference of these two. So we get this. Here we only have a constant that we can move in front according to the second rule. And this one we can write as a power of half. Then using the final rule, this can be calculated. We can also use that rule for that one. And then we get this. Now you just have to remember what this means, this symbol. And that's just to first put in this one, and then take minus putting in this one. Which gives us this. And here we get this. And which simplifies to this. And what's remaining now has nothing to do with integral, that's just calculating. So we can just factorize out this, and now we just take it on the calculator. And we get this. So there was nothing really new here when we had the limits. The only difference is that I have to put in also the limits after you have taken the antiderivative. The formula for integrating by parts also looks the same. We only have to remember to have the limits here. So for example for this one, and here we have f of x is this and g of x is this, and the antiderivative of this one is this. And here we have to put that again and take the derivative of this one, which is just 1. Then we have to put in the limits here, which give us this. And here is just 0, so this becomes 0. And here we can take the fifth outside. And then we just need to take the antiderivative of this one, which is this. And putting in the limits, we get this one, which simplifies to this, which after some calculation just gives us this. For integration by substitution, there are some smaller differences we have to keep track of. So let's take this as an example of doing integration by substitution. Then let's call this y. Then we have that the derivative of y is 2x, which can be written like this. So we have that the y is equal to 2x times dx. And substituting that in here, we see that 2x times dx can just be replaced by dy. And this one is just y to the power of 3. However, now we have a difference. Now we also have to change the limits here, because this corresponds to x being equal to 1, and this corresponds to x being equal to 2. But when x is equal to 1, y is equal to 2. So we have to change that limit to 2, because here it says y equals to 2. And when x is equal to 2, y is equal to 2 squared plus 1, according to this. So we have to put 5 here. And now we can do this. So we get this one. And putting in the limits we get this, which is equal to 609/4. So we see that the only real difference was that we have to change all to the limits here.